Right, very good afternoon to everyone. So today we are going to study our 150 kilowatt practical solar plant. So coming to our skill oriented course, we have solar PV system installation skill oriented course. As a part of this course, we are going to learn the practical design of an 150 kilowatt peak solar plant. So what is the rating of our plant we have in our campus? 150 kilowatt peak solar plant. This 150 kilowatt peak solar plant we are going to design into three segments, where the first segment is 50 kilowatt peak grid connected inverter. Similarly, we have one more grid connected inverter, and similarly we are going to have one more grid connected inverter. Like this, we are going to have three grid connected inverters. Each rating of the grid connected inverter is 50 kilowatt plus 50 kilowatt. How much? 100 kilowatt. 100 plus 50, 150 kilowatt. So resultantly, we have at the top of our building how much rated? 150 kilowatt solar PV plant. Now we are going to analyze this 150 kilowatt solar power plant with respect to number of panels, with respect to open circuit voltage, with respect to maximum voltage, with respect to maximum current. Let's try to have, in our campus we have been developed this plant. The rating of this solar panel is 330 watt peak solar plant. This is nothing but 330 watt peak solar panel. So coming to our panel rating, the first panel rating is open circuit voltage. When you are not connecting the load, the voltage developed by the solar panel is 45 volts. And next one, the maximum voltage developed by the solar plant is 37 volts. So these nameplate details will be printed at the back of your solar panel, that will demonstrate at the top of the building. Next, we have the maximum current as 8.66 amperes. Okay, so these are the specifications of the solar panel. Now we are going to create a group of group 1 solar panel, group 2 solar panel, group 3 and group 4. These 4 we are taking in one session or one array, and next group 5, 6, 7, 8 we are taking to taken second group of solar panel. Now how to design this first string, or like this you are going to have string 1, string 2, string 3 and string 4. Similarly, group of these 8 strings is called as a solar panel array or solar array. So now we want to construct this solar array. So you have solar panel, you want to connect this solar panels in series connection or parallel connection, and try to develop a group of solar array. Now I am going to develop this 50 kilowatt solar array. Like that, how many arrays you have to create? Array 1, array 2, array 3, which will constitute your total solar plant, which will construct your solar plant. So coming to the analogy, so I am taking this string 1. Okay, so here in the string 1 I am going to group 20 solar panels in series connection. Okay, so when you connect 20 solar panels in series connection with a maximum voltage of how much? 37 volts. So what is the maximum voltage that will be developed by this group of panels? So here I have solar panel 1, 2, 3, 4 continued up to 20 number, and I am connecting all these in series connection. So try to multiply 20 into 37. How much? So you are going to get 740 volts. Now what is the maximum voltage across string 1? How much you are going to get? 740 volts. How many panels are connected in series now? 20 number of solar panels are connected in series connection. So similarly, the next string we are going to have, here also we are connecting 20 solar panel with a maximum voltage of 37 volts, which will constitute an voltage of 740 volts. Similarly, in the string 2 we are going to construct how much voltage? 740 volts with 20 number of solar panel. So in the string 4 also we are going to construct a voltage of 740 volts. Similarly, the fifth also we are constructing, actually in our plant design we are reducing one count rather than using 20. We are going to use 19 panels. So now you try to multiply 19 number of panels are connected in series of 19 with operating voltage or maximum voltage of how much? 37. 19 into 37 is how much? 708 volts. Now what is the voltage developed by this series connection is 708 volts. Similarly by the string 6 also, how much voltage? 708 volts. Similarly by string 7, how much is going to generate? 708 volts. Similarly by string 8, we are going to generate how much voltage now? 708. So like this we are connecting all the strings. Okay, so for this we are all these 8 strings or 8 8 strings are there. How many terminals will be there? We have one positive terminal and one negative terminal. Like this it will be having one positive terminal, one negative terminal, one positive terminal, one negative. When you connect in series, the resultant is what? One positive, one negative. You have one positive, one negative, one positive, one negative, one positive, one negative, one positive, one negative, one positive and one negative. All this we have been connected in series now, right? So now let's try to see the analogy. Okay, so and I told that all these are connected in series. In a series connection the current is constant. So what is the maximum current it will flow? The current flow is how much? 8.66 amperes. How much? 8.66. All these 8 panels are connected in to the panel which will constitute the total current. Now let's try to calculate the rating of the each inverter. Coming to the rating, what is the operating voltage? Here you have 740, one group of voltage, and next here you have 708. When you have two different groups, we want to select a voltage which is lesser magnitude. What is the lesser magnitude? Very good. So we are going to have 708 volts. Okay, 708 volts, and all are connected in series or parallel? Series. Okay, therefore we are going to multiply. How many are there? 8 are there. Therefore you are going to multiply with 8 number of panel multiplied with what is the current of the total system? 8.66. 8.66. Just try to multiply this value voltage into current. Automatically you will get the ratings in terms of what? Volt ampere. It's nothing but watts. How much? Okay, 48. Approximately you take it as 50. Okay, so 50 K. So you are going to get resultantly 50 kilowatt peak. 50 kilowatt peak. Now successfully we constructed the first group of panels with how much? 50 kilowatt peak. The same we are going to have 8 strings and we are going to connect them in this configuration which will construct second string inverter. Similar configuration which will construct which inverter? Third string inverter. Okay, now how many inverters are you having? Grid connected inverters? Inverter 1, inverter 2, inverter 3. What is the each rating of the inverter? 50 kilowatts. One segment we are segmenting into 4 at one side, another 4 at another side. First 4, how many panels we are connecting in series? 20 panels in series. In this segment we are connecting 19 panels in series. Okay, so we are going to construct this 50 kilowatt peak system. Okay, now for a given 50 kilowatt peak, how many panels are possible? Okay, so here let's try to calculate how many panels are there at the top of our building. So let's try to calculate for one inverter 50 kilowatt peak. So how many panels are there? 20. Okay, so say the addition of the panel, first string is consisting of 20 panels plus second string 20 panels, third string 20 panels, fourth string how much? 20 panel. What is the total addition? 80. This is one set in our string inverter. Coming to the second thread, you are going to have 19 in series plus 19 plus 19 plus 19. How much this is? 76. Now you add the total set 80 plus 76. How much? 156 number of solar panels of rated. What is the rating of each panel? 330 watts. Okay, so each panel of 330 watt peak. How many are there for one inverter? 156 panels are there for one inverter. Like that, how many inverters we have? 3 inverters. Therefore, to get the total number of panel, 156 multiplied with 3 inverters. What is this value? 468. Okay, so now you got a clarity in our plant what you are there at the top of your building. How many panels are there? 468 panels are there in our campus with how much rated of the plant? 150 kilowatt peak, and they are divided as 50 kilowatt, 50 kilowatt peak and 50 kilowatt. In each 50 kilowatt you have segment 1 and segment 2. First segment consists of how many panels? 20 panels connected in series. Second set consists of 20 panels in series. Third string consists of 30 panels in series. Fourth string consists of 20 panels in series. Second, coming to the fourth string, fifth string consisting of 19 in series. 19 in series, 19 in series, 19 in series. All the things if you are going to group, you are going to get the parallel voltage as 740 and 78. Okay, but as per the electrical engineering, if you have two parallel voltages, whichever the voltage is lower, that voltage you have to consider, that will come into the action. So therefore the resultant voltage is how much? 708 volts. And how many panels are there? Series, we are connecting them in series, and we are having a total current of how much? 8.88, and all these are once again connected in parallel, which will constitute an total number of how much? 18 parallel. So resultantly the system is going to develop as a 50 kilowatt peak. So this is how we are generating. Now coming to the calculation, sir, how many units, kilowatt hour, which is nothing but how many units we are generating from our plant. Okay, so what is the rating of our plant? 150 kilowatt peak. Sir, what is this P indicates? This is the peak amount of power that is developed by our solar system. Okay, so as per the thumb rule, we have every 1 kilowatt plant will generate 5 units. Will generate 5 units. Okay, so per day, how many units? 5 units per day. Per 1 day, each kilowatt will generate how many units? 5 units per day. So like that, we are going to have 150 kilowatt, and each kilowatt will generate how many number of units? 5. So therefore 150 into 5. 750 units. So from our electrical block, how many units you are generating? 750 units we are generating. For example, in the 750 units, 400 units we will consume. So in 750, 400 goes, how many are left? 350. 350 will export to the government, and government will pay the money to us. This is called a net metering system. Already explained in the class. All this comes under on-grid system or off-grid system? On-grid system. This is an on-grid solar PV system. Do you have any doubts?